Alright, so in today's session, let's see a bit on geometries in WPF. Right? So geometries are the basic building blocks of graphical capabilities of WPF. It's kind of abstract wireframe, you can say, of the drawings. So graphs of the geometries can be painted using this path shape. That is a special shape that has been made available to us. And how to draw geometries using path. So more on that shortly. So the uses of geometries are not only drawings, but geometries can also be used to draw brushes and to clip the images, and you can also define shapes of UI elements using these geometries, right? So primarily there are two types of geometries. One is your elementary geometry, and then other one is your complex geometry. So multiple type of elementary geometries can be combined to form a complex geometry. So let's quickly see on how to draw the elementary geometries. All right, so here I have a setup. In this setup, as you can see, uh, I have one canvas. I have drawn specific checkered background to this canvas's background, and so that we can clearly understand the effects of the geometry's drawing. Okay, so let's go full screen on this one so that you can clearly see. So for the demonstration purpose, I will move this panel above and I will scale it to 100%, and then I will highlight only the relevant portion and hide the irrelevant ones. Alright, so here we have this grid and this canvas. On top of this canvas I have drawn one more grid, and within this grid if I draw any UI element it would get overlaid. So in a way this is a transparent drawing setup. Okay, all right, now let's quickly draw a shape, path shape. um, Within this path data I will define one geometry, path geometry, and within this geometry let's start with uh, sorry, let's not do a path geometry, let's do a elementary geometry first. Let's say line geometry, and then let's say start point is 100, that is your x and y coordinates, and your endpoint let's say 350, 600. Right? So here is your geometry, but we are not able to see it because I have not defined any brushes here. Oh, sorry. Oops. Okay. Let's say fill equal Alice blue, and then stroke. Let's say stroke equal red. Alright, so here we have the geometry that we have drawn. So let's make it 400. Alright, so this is the painting. So in short, here we have a line geometry and we are using a special type of shape that is called path to draw this line geometry. Okay, now let's see one more elementary geometry. This is called rectangular geometry. Alright, So rectangular geometry can be defined by the rectangle. So let's say the rectangle is from left at 250 pixel, and then from right, let's say it's again 250. From top it's 250 pixel, and then the width, let's say 500, and then height 500. Oh, okay, this is not too much. How about this? Good, good. All right. How about one elliptical geometry? Let's see. Let's say the center is at 150, and then the major axis, that is your radius x, equal 100, and then the minor axis, which is defined by your radius y, let's say it's 80. Right? Here we have this elliptical shape that is defined by this elliptical geometry. So that's it. Now, what if we have to combine more than one elementary geometry and then form a geometry which is constituted or defined by these two or more geometries? So for that, we have one geometry called geometry group. Now, if we define two ellipse geometry here, say the center is at 250. Oh no, 250 would be too big. 100, and then radius is say 100, and then radius y is say 80. Then let's repeat this. Okay, now let's make the center as 200, 100. So here we have a geometry which is drawn using two elementary geometries. Not only two, we can repeat this one more time, and then we can have one more geometry included. So the result is a combined geometry which is uh, drawn using certain algorithms. All right. So as you can see, the inside area or the overlapping area or the intersection area of these ellipses are transparent. So as you can see here, this portion has not been painted. So why is that? That's because the fill rule is even odd. Now if I change it to non-zero, then it paints the union region of these three geometries with opaque color. So what exactly is this fill rule? This fill rule actually defines which all region would be outside the geometry and which all regions would be the inside region of this resultant geometry. So as the name specifies, the non-zero part, that means any region which is overlapped at least by one geometry, then that area would be considered inside region in the resultant geometry. So as you can see here, this area is not overlapped by any of the geometries. So that's why in resultant geometry this is still outside, and these areas are at least occupied by at least one of the geometries. That's why these areas are inside this resultant geometry's region. Now let's change it to even odd. Here now you can see that this area is overlapped by two geometries: this geometry, the second geometry, and the first geometry. Now since this area is overlapped by two geometries, 2 is an even number. That's why this area is outside the final resultant geometries region. Now similarly, if you see this area is also overlapped by this second geometry and the third geometry. That's why this area is overlapped by even number of geometries. That's why it will be considered outside the region. Now let's draw these overlaps so that some of the region are overlapped by three geometries. All right, so let's say it's 150. Now as you can see here, this region is overlapped by, okay, this is a bit confusing. Let's clear this up and let's draw the center as 200 200. Now it's clear, or rather let's make this 150 200. Yeah. Now as you can see here, this area this area is overlapped by three geometries: first, second and third. This area is common to this all these three geometries. Now 3 is odd. Since this is an odd number, that's why it would be considered inside the inside region of the resultant geometry. But if you see here, this region is overlapped by two geometries, this one and this one. That means first and second one. That's why this area, which is evenly overlapped, that means overlapped by even number of geometries, that's why this would be considered outside. So the rule is, if any area is overlapped by even number of geometries, then it would be outside region, and if it is overlapped by odd number of geometries, then it would be considered inside region of the resultant geometry. That's how this field rule drive the final uh, geometry as a whole. All right, now this is a geometry group. Now one more geometry is there, that is your combined geometry. Now in this combined geometry you can have only two geometries, geometry 1 and your combined geometry 2. Now in this geometry 1 you can have any kind of geometry. It can be elementary geometry, it can be geometry group, or there could be a combined geometry within this geometry 1. All right, now for the sake of brevity of this example, let's consider ellipse geometry here. All right, now ellipse geometry, let's say center is again 150 150, and then your radius x is 100, and then radius y is 80. All right, now let's copy and paste it here, and now let's make it 250 150. Now this is the resultant geometry. Now I can specify here combine mode. Now if I make it intersect, then it gives me the intersection region only. If I make it XOR, it will give the exclusive OR regions. That means the not of intersect. Okay. Now if I make it exclude, it will give me the left geometry only. And then if I make it union, this is the default one. It gives the union region of both the geometries. All right. So this is your combined geometry. So these combined geometry and geometry group can be formed either by elementary geometries or any other kind of geometries like the combined and geometry group. Now there is one more geometry which is of special interest to us, that is path geometry. Now let's say I want to draw a complex path. How do I do that? In path geometry I can define the figures. Uh, Figures are the basically the data using which the path geometry will be drawn. Now within these figures there has to be at least one figure. There can be multiple. So again, for the simplicity's sake, I am keeping only one path figure. Now within this path figure, let's draw a line segment. Now let's say it's drawn till 100 comma 100, right? So as you can see here, the line has been drawn from 00 to 100 and 100. Now if I want to specify it should be drawn from 50-50, then here I have to specify the start point as 50-50. As you can see here, a line has been drawn starting from 50-50 to 100-100. Right. Now what if I want to continue this path and draw one arc segment here? Let's say sweep direction is clockwise, and then size is 10 comma 10, and then point is let's say 150 comma 150. All right, how is that? It has drawn arc, and then the last point has been joined to the first point, initial point. Okay. Okay, all right. Now let's try to draw one interesting geometry using path geometry. All right. Let's see. Uh, let's start it from 1080. Okay. Now let's draw arc segment here. Let's say the sweep direction is clockwise, and then sweep direction is clockwise, and then your size, let's say 20-20, and then let's say point is 110-80. How about that? All right, sounds good. Now the second one, let's say I want to replicate this part, I mean extend this the same pattern to the next half. So I will start from 110-80, and then I will keep it to, let's say, 210-80. Right. Now I want to extend this to one more line, say line segment, and then point is from the midpoint. That means 110 comma, let's say I want to add 100, that means 180. How about that? Looks good. So this is how you draw a complex figure using this path geometry. So you can include many other type of segments. Now if I say segments, you can see here Bezier segment is there, poly-Bezier segment is there, poly-quadratic Bezier segments are there, quadratic Bezier segments are there. There are uh, n number of segments are there. You can use any one of them. Alright, so this is all about your geometry. Now the question is, how do I use these geometries? Now one obvious point is we can use these geometries to draw the underlying graphic, so the way we have drawn. Now the other use is we can also clip any images. So let's clip one image here using this path geometry. Right. Now let's say we define an image. Source is slash pics. I have one pic folder within this slash flowers. No, it's not flowers.jpg. Yeah. Oh, great. Now let's size it. Width equal, let's say 500. Height, let's say 500. Right. So I have a decent picture here. Now what I want to do is I want to clip the picture using this path geometry. Now let me copy this path geometry here and let me delete this thing. Alright, let's say image dot sorry clip. As you can see, the geometry we have created earlier, so that geometry is used to clip this image. Alright, so that is how we can use geometries to clip image and produce good effects. Now the other use could be we can draw a button and use this geometry to shape its uh, overall drawing. Now let's try this. uh, I'm again copying this path geometry. I'll get rid of this image here. Let's define a button. Let's say width is 400 and then height is 400, and then button dot clip is this geometry. Now you can see the, let's say, uh, background is red. Now as you can see here, this button has been drawn and then it is clipped by using this path geometry. Right, so this is another use of geometry. Now another interesting use would be to use this geometry to paint use this geometry to create a drawing brush, and using the drawing brush paint a rectangle or any other shape or maybe any UI element. So for the sake of brevity, let's use a rectangle. Now let's say width is 400 and then height is 400. Alright, now let's say rectangle dot fill. Fill uses a brush. Now I will use this geometry. Okay, sorry, I will use a drawing brush. Now in this drawing brush, I'll have a drawing. Within, I will have a geometry drawing rather. Yeah. Now within this geometry drawing, I will paste this. Right? Path geometry. Now within this geometry drawing, I will have to put the geometry. And here, path geometry. So what I have done here is I have created a rectangle and fill, within the fill property of this rectangle we specify a brush. Now I am saying that I will supply a drawing brush to fill this rectangle. Now how that drawing brush uh, is created is by using this drawing. Now what is the type of drawing that I am supplying here? Now I am supplying a geometry drawing. Now how is that geometry drawing created? Now that geometry drawing has been created by using a geometry. Now how is that geometry created? Now I have used a path geometry to supply the geometry. Now that's how the rectangle will be filled. But right now I can see here that this rectangle is not filled at all. Now let's see, uh, in this geometry drawing, let's say brush is red. Alright, so this geometry has been completely filled by one big drawing of this geometry that we have supplied, but I don't want this effect. I want to supply um, I want to um, use the viewport as say 100 by 100 size of drawing, and then let's say unit is absolute, and then let's say tile mode is tile. Okay, sorry, the viewport is should be 0, comma 0. Yeah, now this looks better. Now what I have specified here is I want to create a brush using this geometry. Now when this geometry is formed, I want to fill that a block of 100 pixel by 100 pixel by that geometry, and I want to fill this whole rectangle using that pattern. Right, now I can specify stretch here. If I specify stretch and then make it uniform, the aspect ratio is maintained. Now if I specify uniform to fill, then aspect ratio would be maintained, but it will be enlarged to fill the whole 100 by 100 pixel area. This is how it looks. Now I don't want this. Uniform is far better. Okay. Now more on this tile mode, viewport, units and stretch would be available in my another video called when I give the demonstration on brush. So when I talk about brush, I can talk a bit more on this viewports and tile mode. So for today's tutorial, which is on geometry, that would be it. So this is the use of geometries. So just to recap, you can use this to draw a painting, to clip an image, or to clip an UI element, or you can use any drawing to create a brush and use that brush to fill any shape or UI element. Alright? Alright, so that was it for today's video. Thanks for watching.